Hello, everyone. I am Safwat Alshazly. I am a technical training advisor at NetWitness Educational Services team. And today's session will be about the NetWitness event stream analysis. So before we start our session, let's go through the session agenda. The session includes 4 topics. We'll start with identifying ESA and exploring a use case for it. Then we'll move to ESA components and recognize some important terminology that will help us throughout the session. The third topic of this session is about the sequence of generating the ESA alerts. And finally, the fourth topic is about creating ESA alerts, and we will watch a video demonstration that clarifies the required steps to do so. Okay. So before we start our session, please ensure that your mics are muted. If you have any questions during the session, please drop them at the chat box so that I can answer them at the end of the session. And also do not forget to check our course catalog. After the session, a PDF version of this presentation will be sent to all of you, and you can click the Visit Course Catalog icon, as you can see here. Okay, let's start by setting your expectations from this session. We will cover the introduced topics, which means ESA definition, components, terminology, sequence of generating alerts, and main steps of creating ESA alerts. But topics such as adding a deployment or configuring enrichments are not included in this session. The fourth topic includes a video demonstration for creating ESA alerts. I will go through the video and explain every part of it, but I will leave exploring ESA on the NetWitness UI itself to you, of course, if you wanted to. So first, definition and use cases. As a general concept, event stream analysis, or ESA, is a reactive programming technique that processes data from a data streaming source as the data comes. By processing, I mean filtering, analysis, aggregation, and pattern recognition. The NetWitness platform leverages ESA to extend its functionality. So as a result, it empowers the NetWitness platform with a near real-time correlation and complex event processing of log and packet meta. Complex event processing enables you to process multiple events with the goal of identifying the meaningful events within the event stream. Also, ESA enables you to detect complex patterns of many events, event correlation and abstraction, event hierarchies, and relationships between events, relationships such as causality, membership, timing, and event-driven processes. Also, ESA helps you store alerts and alert meta. How? Normally, meta is passed through the ESPER engine, and I will shortly talk about ESPER. So meta is passed through the ESPER engine and then ceases to exist at that point. If an ESA alert is fired, the necessary meta is stored in the database. Otherwise, it is discarded. That's how ESA helps in storing alerts. If you noticed, I mentioned the term complex event while talking about the ESA features. A complex event is a series of events that, when occurring in a particular order, create a particular result. I also mentioned correlation. What I mean by correlation is the analysis of the complex event within a specified time window, such as a series of failed login attempts followed by a successful attempt within a 1-minute time window. And I'm stressing these words because we're going to see that later in the demonstration. Let's now say that I want to detect a specific complex event using ESA. What I want to detect is that, and this is the complex event, if a user logs into a computer, SSHs to a Unix server, then this user transfers via SCP a badbytes.sh, for example. So he transfers via SCP a bad script to a file server, executes the script, and finally logs out from the computer. ESA helps me detect such complex events even if it occurred within a period of a day, a week, or even 10 minutes. Okay. Let's now move to the second topic, components and terminology. First, let me emphasize on an important point here. What I mean by components is not the classic meaning of it. So it's not like some libraries that make a specific piece of software. That's not the case here. What I mean by components is that for ESA to function on NetWitness, the parts that you're going to see shortly, these parts of NetWitness cooperate together or used, you can say, for me as a user to be able to utilize ESA features. So you can consider them logical components, something like that. The first component is rules, which are the queries written in the Esper programming language that trigger alerts when matched. These rules create alerts based on data in the NetWitness database using conditions or notifications or enrichments, or all of them. Then we have services, which help view statistics for ESA and enable and disable rule stats. We also have settings, which help view available meta keys and create sources for enrichments and data connections. Then we have deployments, which are the lists of the ESA rules that have been deployed to an ESA device. These deployments associate a rule or more with a specific ESA service or more. They are not covered in this session, but they are part of ESA. Finally, we have respond, which helps view results of alerts and drill into these alerts. Let's now introduce some important terminology that is of a great value during this session and maybe even afterwards. Rule templates are responsible for converting what you write in the NetWitness UI into code so ESA can understand it, while a rule library is a list of all the ESA rules that have been created. So don't get confused between both of them. We also have a constituent event, which is a term we use to talk about all the events involved in an alert, including the triggering event. Then we have Esper. I promised to talk about that. Esper is a software product that offers EPL, and EPL stands for Event Processing Language for complex event processing. So Esper is used to analyze a series of events, and we'll see a sample of that in the demo. Generally, when we say Esper or EPL in this context, we mean the programming language. So you may use them interchangeably in this very context. And finally, the Esper engine, which you can guess, is the software that makes complex event processing, or CEP in short. So it makes CEP possible by processing the commands written in Esper. Let's now talk about the sequence of generating alerts in ESA. Now that we identified what ESA is and realize its components, it's time to know the sequence of which ESA generates alerts. First, the ESA correlation service runs rules that specify criteria for complex events in your network. Then, receiving meta. ESA receives meta from concentrators that are configured to send meta. Afterwards, ESA gathers the data and runs the correlation rules against this data. ESA then captures events that meet the rule criteria and generates alerts for these captured events. And finally, the ESA alerts are shown in the respond module, and incident rules can leverage alerts to create incidents. Note that alerts generated from a rule can incorporate additional information, such as risk score, the supervisor of the employee to which the alert pertains, or even the name of the user. Now talking about creating ESA alerts.